maybe. There we go. All right. Yes. So that warm up was kind of the same idea as we were working with yesterday, and today is going to be very similar to what we were working with yesterday as well. We're still identifying angle bisectors and perpendicular bisectors. We're using them to find missing measures. We're also going to take a look at when we can and cannot use the perpendicular and angle bisector theorems. Like problems like, do we have enough information in order to use this theorem? Because sometimes we get into the habit of going, oh, well, I was told I could, this problem set is about this theorem. I must be able to use it. But that's not always the case. So we want to make sure we take a look at that. So if you haven't already, go ahead and pull out whatever it is you're using to take notes, and let's get going. That one. Okay. So 6.1 angle and perpendicular bisector. Well, Well, all right. Spelling is hard. Bisector is what that says. Theorem. Day 2. Okay. So the first thing that we're going to kind of look at is identifying when something's an angle bisector versus a perpendicular bisector, especially in the context of triangles. So, identifying bisectors. So I'm going to draw a couple of pictures, and we're going to identify if it's an angle bisector, a perpendicular bisector, or neither one of those. Actually, for number 4, that's the same as the picture that I drew over there. So instead, on number 4, we're going to do that. Okay, so on all 4 of these, we're going to identify, is it an angle bisector, a perpendicular bisector, or neither one of those things? So starting with this first one here, what do we think? What's going on in this picture? Is this an angle bisector, a perpendicular bisector, or neither one? Yeah, the line cuts the angle in half. So since the line cuts this angle in half right here, that's a good indicator that we're dealing with an angle bisector. So there we go. What about this one here? We've got a line and it's going through this triangle. It's cutting one of the sides in half. And we've got a right angle right there. What do we think for that one? Well, we know it's not an angle bisector because an angle bisector looks like this where it's cutting an angle in half. Could it be a perpendicular bisector? Perhaps. Yeah, I think so too. Because it's a line, it's cutting a segment in half, and it's perpendicular to the segment. This meets all the requirements for perpendicular bisector. All right. How about this one? What do we think? Is it an angle bisector? You're right, Marissa. This one is neither. Because it's not cutting the angle in half, and it's not perpendicular to anything. So this one, although it bisects this side over here, it's not an angle bisector, it's not a perpendicular bisector. So this one would be neither. It's actually a median, but we'll get to those later on. All right, what about number 4? Does that look like anything we've seen before? I mean, maybe if you've gone over triangle special segments before, but this one is also one of those ones that, although it cuts both of these sides in half really nicely, this one is also not an angle bisector and not a perpendicular bisector, so this one is neither. All right, there's one more case I want to show you guys. Spoiler alert, this one's also going to be neither. So if we get something like this, where it's perpendicular, it's not necessarily a bisector, unless these are labeled as being the same, or these are labeled as being the same. Then in that case, you would be able to tell that it's a perpendicular bisector, but this would also be a case where it is neither. Because although it's perpendicular, it's not a bisector. Okay. So in order for it to be a perpendicular bisector, it needs to be two things, perpendicular and a bisector. In order for it to be an angle bisector, it just needs to cut the angle in half. That's all. Okay. So those are some cases that you'll see within triangles that we want to be aware of. And you'll see more and more of those as we start 6.3 and we add a couple more special segments to our list. The other thing that we want to talk about today is when we can and can't use the perpendicular bisector and angle bisector theorems that we learned yesterday. So, kind of moving on to the next thing here. When do we have enough information to use bisector theorems? Okay, so real quick, let's refresh our memories on what those theorems were. So we had the perpendicular bisector theorem, and we had the angle bisector theorem. So that was if we have a point on the perpendicular bisector, then that point is the same distance to the ends of the segment. And then for the angle bisector theorem, we had if we have an angle bisector and there's a point on that angle bisector, then that point is the same distance to both of the sides. So remembering those, and we want to know when we have enough information to use them, that means that we have to have something like this. We have to have an angle bisector with a point on it in order to say that these distances are the same. In this case, we have to have both the perpendicular part and the congruent segments part in order to say that these two segments would be congruent. So if we don't have a picture like this with this much information, or a picture like this with this much information, then we can't use the bisector theorems. And the same thing goes for the converse, just flipped around. So, for instance, if we have a picture like P, Q, R, S. We might be asked the question, is this enough information to find the length of PR? Adon says no. What else would I need? Anyone help us out here? Yeah, we would need to know, like, we've got this perpendicular part here, but I don't know if it's a bisector because we don't have that QS and SR are the same length. So I would also need to know that those two are the same in order to say that this is also 81. So we would need QS and SR to be the same. We would need to know that it's a bisector. We have the perpendicular part, but we don't have the bisector part. So that's a problem. Another example where there's not quite enough information. Can I use angle bisector theorem to find AD? And this one's the one that we have enough information because I don't actually know if this is an angle bisector. So we would need to know that angle DBC is also 26. Okay, so those are some of the cases that we might see where there's just not quite enough information that we want to be aware of. In order to use perpendicular bisector theorem, you need it to be perpendicular and a bisector. In order to use the angle bisector theorem, it needs to bisect the angle. So it's just kind of following the definition of those items. We need to actually have a perpendicular bisector or an angle bisector in order to use the theorem. And that's really the only difference in types of questions that will be asked today. So looking at what we've done so far, are there any, is there anything we're wondering at the moment? Any questions, any numbers we don't know where they came from, or definitions we're still kind of fuzzy on? Okay. Keep in mind, if at any point you do have questions or anything like that, feel free to unmute yourself and say so, or type in the chat as we go. But that's really the main thing I had for you guys for today. So we're going to get to the assignment, and you guys can use the rest of the time in class to get it done and hopefully not have too much work to do later. So back to Google Classroom. Today we will have our typical assignment, and then also the Google Form exit ticket that we're going to get in the habit of doing most days. So first things, the assignment, we're doing 2 IXLs today, one about perpendicular bisectors, the other about triangles and bisectors. So usually like angle bisector theorem, that kind of thing. It's IXL B8 and M2 from geometry. I'll put that on there and we'll take a look at it. Okay. So B8 is going to have perpendicular bisector questions, like if CF and EF are the same and CD is 68, what is DE? Well, it would also be 68. So this kind looks just like our warm-up from today. And then the other kind is going to look a little bit more like angle bisector type questions. So we've got, let's see, QSR and QST, and QR is 53. Let's see, where's QR? Then QT would also be 53. It's just that in this case, this is the angle being bisected, and this is the bisector. Oops, not 63, 53. Come on. And then some of the questions will be perpendicular bisector questions. Some of them will be, like in this case, this is the converse of the perpendicular bisector theorem because we know that this is perpendicular. And we only know it's a bisector because these two segments are equal. So this was that converse one. So FG would also be 24. Okay. So that's kind of a mix of both types of questions there. And I think we're good on recording.